in the previous video, I gave you a function like this, and then asked you to find out the gradient of this thing here. Find out the gradient of this whole thing here. But from now on, we're not going to say find the gradient of blah blah blah. We're going to say find the derivative of blah blah blah. So when you see find the derivative of this thing here, you can pretty much think of it as find the gradient of this thing here, of this whole thing here. Okay, so from now on, I'm going to give you something like this, and then find it, and then ask you to find the derivative. That pretty much means find the gradient of this thing here. Okay, so to do that, always start out by sketching this function here. So start out by drawing a graph. Okay, once you've drawn your graph, set up this system here. Set up this system here where you've got point A, point B. This is at x, and this is x plus h. And then think inside your mind. Say to yourself inside your mind, the gradient that exists between A and B is given by this. The gradient that exists between A and B is given by this. But the true gradient is when you start to decrease h. So the true gradient is when you take the limit of this thing here. Okay, so the true gradient equals this thing here. But the thing is, we're not going to use true gradient. We're going to use well, if you think about it, hang on. If you think about it, the gradient is really this thing, this height here divided by this base here. But this height here is really the difference between this height here is x plus h, take away x. It's really the difference between this and this height. Well, it's really you getting this length. It's really you getting this length, and then taking away this length here. It's really you taking the difference of this and this here. So it's really you. Well, this bit here, you can think of it. Well, let's just say it's dy. The difference in the y direction. Okay, so this height here is really the difference in the y direction. This height here, we're going to say dy, and then this here is really the difference in the x direction. We're going to say dx. Okay, so rather than saying true gradient equals blah blah blah, we're not going to use true gradient. We're going to use dy by dx. Okay, because if you think about it, the gradient is really this thing divided by this thing here. Well, this thing's the difference in height. Well, it's different in the y-axis, and this here is the difference in the x-axis. So the gradient really, you can think of it as dy divided by dx. So from now on, rather than saying true gradient equals blah blah, just say dy by dx equals blah blah blah. Okay, so set up. So first, well, from now on, I'm going to give you y equals blah blah blah. So start out by drawing your graph, and then set up this system here, and then inside your mind think, the gradient that exists between A and B is given by this. But then the true gradient, well, then you can think of it as dy by dx is when you take the limit of blah blah blah. Okay, and then you would do your usual thing by putting this x plus h into your function, and then take away blah blah blah. I've done a whole video on this, so watch a previous video, and then do all your argy-bargy stuff, and then that would take you to here. Hang on. Remember, I've done all this in the previous video. So you would get to this stage here. Well, this thing here is now, well, earlier I gave you y equals, I think it was 3x squared plus 5x minus 7. This was our original question here. But now when we got to this stage here, you can write dy by dx equals 6x plus 5. Okay, so I would give you something like this, and then you got to find out dy by dx in effect. Okay, once you've got this here, you can find out the gradient at any point. So suppose you want to find out the gradient at x equals 1, then you would just put 1 into here. So you can say that when x equals 1, dy by dx equals 11. Okay, so you can, well, the important thing is I'm going to give you something like this, and then you have to find dy by dx. dy by dx is really the true gradient. The true gradient is this thing here, and it depending on where you want to find out the gradient, you can just say when x equals blah blah blah, dy by dx equals, well, you would just put this into here. Well, anyway, find it. I would give you something like this, and then I would ask you find the derivative of this, or the derivative of this is dy by dx equals blah blah blah. Okay.